Now, ionic compounds are done differently because we're no longer showing a sharing of electrons. This time we're showing the transfer of electrons. Now, all ions are put in square brackets, and that's really important. And positive ions lose their valence electrons so that they have a full outer shell. But as we're only showing the valence electrons, they'll have nothing around them in the final result. Negative ions have a complete octet because they gain electrons. Now let's try an example. I look at this example and I say to myself, sodium is a metal, chlorine is a non-metal, and they are existing as ions. This is an ionic compound. Now, because I've asked myself, oh, it's ionic, I have to show a transfer of electrons. Now, what I'm thinking is sodium starts with one valence electron. Chlorine, on the other hand, in group 17, has got 7 valence electrons. Sodium will end up transferring its valence electron to chlorine. This will result in sodium having no valence electrons and having a charge of +1. Chlorine, on the other hand, has now gained an electron and has got a complete outer shell with 8 electrons around it, and it has a -1 charge. So you can see that it's shown in square brackets, the positive on the negative ion. The sodium, losing its valence electrons, now has a complete shell, but we don't show it because it wasn't one of the valence electrons to start with. Chlorine has now gained sodium's valence electron and does show the complete shell. Now let's try another example, calcium fluoride. Now we know that calcium has got 2 valence electrons, and each of the fluorines have got 7 valence electrons. So calcium transfers its valence electron to the fluorine here, and its other valence electron to this fluorine here. This will result in calcium losing 2 electrons and becoming a +2. Now at this point in time, remember, it now has a full shell. Now we've got 2 fluorides, each with 8 electrons around it. And there we have our electron diagram. This time we're going to try aluminium chloride. Now aluminium is in group 13, so aluminium has got 3 valence electrons. Now each of the chlorines, being in group 17, have got 7 valence electrons. Remember to keep your electrons in pairs. So this aluminium will transfer 1 valence electron to this chlorine, 1 valence electron to this chlorine, and 1 valence electron to this chlorine. This will result in aluminium losing 3 electrons and becoming 3 positive, so I'll put it in the square brackets. And I have 3 chlorines, each with 8 electrons around the outside and a charge of -1. Now let's try a more complicated example. Sodium sulfate is considered to be an ionic compound because we have sodium ions and sulfate ions. But this compound also contains covalent bonding within the sulfate ion. So this one is going to be a little bit more complicated because we have to show both types of bonding. So we already can see that there's got 2 sodium ions. I'm just going to draw them in 2 sodium ions. And we know the sodium has a charge of +1. Now the sulfate is an ion, and we tackle it like a molecule because it's got covalent bonding. Each of the sulfurs has 6 valence electrons, and the oxygens, each of the oxygens also have 6 valence electrons. But because it's got a 2 negative charge, we have to add 2 extra electrons. Now we need to add them up. 4 6 is 24, over 6 is 30, is 32 electrons. I'm going to put it in the square bracket because it's going to be the ionic. From this, it looks like sulfur is the central atom, so I'm going to put oxygens around it. I'm going to start by putting in single bonds. Then I need to complete the octet around it. Keeping the electrons in pairs. Check for electron count. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 29, 30, 32. I've used 132 electrons. Does my central atom have 8? 2, 4, 6, 8? Yes, it does. Charge on, and wow, I've got 8. Now try a few yourself. Go to the OneNote, bonding, ionic and ionic compounds. After you've done those, go to Starless F17. Now Starless F17 has got a mixture of both molecules and ionic compounds. So this will always require you to ask yourself the question right at the beginning, what